LISP network virtualization and multi-tenancy in hybrid model. In this video, I'm going to talk about the hybrid model. You know that in previous videos, we learned about the shared model and also parallel model. What is the hybrid model? Hybrid model is a combination of the shared model and also the parallel model. Okay, in this scenario, I'm going to show you how we can implement the hybrid model and one of the usage of the hybrid model. But let me to say that for understanding this scenario, you need to understand first the shared model, after the parallel model, and also you should have enough time for this scenario, because maybe this scenario is one of the longest scenarios that you implemented until now. Because of that, you need to watch this video with the knowledge that you have about the shared model and also the parallel model. After that, in this video, you can understand the features related to the hybrid model. Okay, let me to talk about a little more about the hybrid model in this scenario. Look at here. Here we have one backbone carrier. Okay, in this backbone carrier, we have a structure. For example, the router 4 is the MS and MR, and also router 1, router 2, and router 3s are XTRs of this service provider or backbone carrier. Okay, after that, this backbone carrier has two customer carrier. As you can see here, we can see the for example, relation between the carriers. The first customer carriers, this is a service provider also, but it is a smaller carrier, the SP1, okay? And the next carrier is the SP2, service provider 2. This means that in the backbone carrier, we have two customers. Okay, the first customer is the service provider 1. It is also a service provider, but the service provider 1 is the customer of the backbone carrier. We call it customer carrier. After that, also we have another customer carrier, service provider 2. Actually, as you can see, the service provider 3 or SP3, the backbone carrier, should connect the different sites of the customers carriers to each other. For example, this site XTR5, this site MSMR7, and this site XTR9 are sites of the service provider 1. Okay, and the sites the XTR6 and MSMR8 and XTR10 are the sites of the service provider 2. First, this backbone carrier should connect these service providers carrier sites to or customer carrier sites to each other. After that, here you know that we are using the parallel model, okay, such as the previous scenario. For example, we have two RLOC space in the backbone carrier and also two logical separated underlay for each RLOC space. After that, we will have connectivity between the service provider 1 sites and also service provider 2 site. And then here, each service provider, okay, has some VPNs or has some customers. For example, here is the customer A site 1 and here is the customer A site 2. As you can see here, the customer carrier service provider 1 has two customers, customer A and B, as you can see, A and B, and customer carriers service provider 2 means service provider 2 has two customers C and D. And we need to finally for example, giving the connectivity service to customer A in service provider 1 means site A1 and site A2, B1 to B2, and then to the customers of the service provider to customer C and D, C1, this is the C1 site, this is the C2 site. These two sites should be connected to each other, and also D1 and D2. You know that in the layer of the customer carriers, means service provider 1 and service provider 2, we are using the shared model. Look at here. Here we are using the parallel model. Here we are using the shared model. Okay, you will understand the detail. But for now, let me to say, in the backbone carrier, we are using parallel model. This gives each service provider or each customer carrier a separated physical or for example separated underlay and also overlay, okay, parallel model. But in the for example, in the layer of the service provider, in the network of service provider 1, we are using the shared model. This means that we are using the same underlay, and only we are using one RLOOK. Okay, you know that in parallel model we need to use two RLOOK for example, each VRF, for example, VRF SP1 and SP2, such as the previous scenario. But in the R5, because we are using the shared model, we are using only one RLOOK for both sides of VPC1 and VPC2. I will implement it and you will learn it. Don't worry. The only things that you need is the knowledge of the shared model and the, for example, parallel model. Let me first configuring the connectivities between the service provider 1 sites and service provider 2 sites in this first step, means the parallel model. After that, we will implement the next step. Look at here. Here we have the configuration. I configured this scenario before, and only we need to review the configuration, okay? Because of that, let me to start with the router 1. You know that here we are using parallel model. Because of that, such as the previous scenario, you need to create two virtual networks in the service provider 3 or backbone carrier. Let me to start. EN, the router 1, conft hostname XTR1. This is the XTR1. Here, first, I'm going to configure two VRF for two RLOOK. Look at here, in R1, we have two customers, service provider 1, service provider 2. And we want to use for each customer one different RLOOK space. Because of that, here I am configuring the VRF definition RLOOK 1, and also address family IPv4 unicast can help us to enabling the IPv4 in the RLOOK 1 address space. And then VRF definition RLOOK 2 address family IPv4 unicast. These two VRF are the RLOOK VRF, you know it. After that, we need two VRF for the service provider 1 and service provider 2. As you can see, VRF definition SP1, the VRF for this service provider, VRF definition SP2 for this service provider. And now we can assign the IP addressing to the interfaces. First, let me start with the ETH00. Interface ETH00, no shutdown. Here, as you can see, I configured one sub-interface, interface ETH0 0.1 encapsulation.1q1 VRF forwarding RLOOK 1. The interface ETH001 is the member of the VRF for example RLOOK 1, and then IP address 10141, then 255.255.255.0. So easy. Look at here, the IP address is between the link between router 1 and router 4 is 10141. Also, here I configured interface ETH00.2 encapsulation.1q2 VRF forwarding RLOOK 2, and then IP address 10141.255.255.255.0. If you want to understand the process, you can use this algorithm. Look at here, it is so easy. Only for better understanding, I'm using this diagram. Look at here, we have R1. In R1, we have ETH00. Let me to configure for or draw for you the logical diagram. Interface ETH0 0.1 now is connected to the R4, to R4 ETH, okay, 0.1, and then here we have on the ETH02, ETH02.1, this is connected to the router 3, this is the router 3, again ETH0 0.1, that's it. And also here we have another interface in the router 4, this interface is ETH, okay, 1.1, and after that, with this interface we are connecting to the router 2. Let me to show you, this is the router 2, and this is the interface of ETH0 0.1 of the router 2. So easy. Okay, this is the virtual network for VRF RLOOK 1. This is for VRF RLOOK 1. Okay, also for VRF RLOOK 2 we are using the same diagram. Okay, VRF RLOOK 2. Okay, but here we are using interface ETH0 0.2. Again, here is 0.2, 0.2, 0.2, 0.1.2,